constantly see on the forums people coming in there all excited because they just discovered DIY, and they go to a website like Solon or Parts Express or Matasound, and they find these really cool drivers and they think, hey, I can build speakers. But the problem is they then go to some Google found site where they can calculate a crossover and think, yeah, this is no problem. I'm going to pick X driver and Y tweeter, put them in this cool box because I'm a really good carpenter or whatever. Wham, I've got a speaker. I'm going to show you today why that is a really bad idea and why it doesn't work. To demonstrate the difference, I'm going to use a speaker design I've been working on for a while. I call it the Life S9. It's not your typical two-way bookshelf speaker, it's a little different, but it's what I had working on right now. I'm in the middle of painting it, so it looks a little funny with the masking tape on it and things like that, but I can assure you it's a really good speaker. This is the speaker I'm going to be using right now. You can see the masking tape and things like that. It uses a Dayton RS woofer and a COS10 with the DNA 360 compression driver. This is the crossover that I've developed for it. It's already on the board and ready to go, so I hook it up to the speaker to get started. Once it's hooked up, I can take a measurement to get the baseline performance of the speaker. Microphone is 1 meter away, and there's my measurement set up. Here we go. So here's the results of the crossover that's been designed properly. Relatively flat response. You may notice a bit of a peak at about 1200 Hertz and another peak way up at about 17,000 Hertz. You really can't hear that, guys. I know lots of people like to nitpick that stuff, and if you can hear it, well, sorry, these compression drivers are not for you. But in general, this is a pretty good response. I can tell you that it does sound good. So here we have a good performing speaker. I can now take off that crossover that's been designed well, so I can start the design of the crossover calculators. Usually people go to the spec sheets and they find the frequency range of the speaker, and so that's what I'm doing here, and I think we're going to use 1500 Hertz. So we go find a crossover calculator. We're going to go with the two-way 12 dB per octave slope and punch it all in and start finding components. Yeah, that was quick. 0.6 on the woofer. And there's an 18.8 right there. This Solon 6.8 and Benick 2.7 come very close to 9.4. While I'm at it, I'm going to give it the benefit of the doubt that someone who's doing this knows they need an L pad. So I'm going to take the sensitivity differences between the drivers. I got this box of resistors here. I'm going to use that same website to calculate the L pad required and put that on here too. So when we go back to the spec sheets, we can see the sensitivity of both drivers, subtract the difference, and then go back to our crossover calculators and use the L pad calculator and pop those numbers in right there, and we get our values for our resistors. I have a 6.8 instead of a 6.9, and I have a 12 and a 1.5, which in parallel will make 1.33. So I'm pretty darn close on all these component values. I'm going to solder all the components together, even though alligator clips would be far faster, just because I figure I'll get better connections, it doesn't take long to do it, and then ultimately no one can say to me, hey, you had a bad connection or something like that, I don't trust these results. Okay, now that that's all soldered up, I can hook it up to the speaker. This is good to go. And there's the difference. The green is with the textbook crossovers, and the red is my original good design. Looking at the results, you can see they're vastly different. We've got big problems down in the upper bass. We've got a giant null around 1200 Hertz. This is because of phase. The drivers are not
cooperating in this region, and then they start to cooperate above 2000 hertz. Overall, this does not look very good, and I don't think it would sound good.
So at this point you might be thinking, hey, I can see now that, yeah, those don't work, but why? Why don't they work? So the first thing I do is take frequency response measurements of the drivers without any crossover, and you can see that they're not straight lines. So right off the bat, this doesn't work.
Here you can see the frequency response of the woofer just isn't quite what the manufacturer claims as far as extension goes. In hindsight, I wouldn't even use a 1500 hertz crossover with this woofer.
The other thing I do is whip out the impedance jig and take impedance measurements of each drivers. But you can see here in the woofer measurement that it's not a straight line either.
So you can see here that it's only 4 ohms at 2 places. It's a 4 ohm nominal woofer, but impedance changes with frequency. And you can see above about 1000 hertz, inductance really takes over. And if our crossover is set at 1500 hertz, and crossovers are not a brick wall, they extend beyond 1500 hertz, the impedance is climbing very quickly. So our calculator has no idea that we're looking at 6, 7, 8, 10, 12 ohms, and it can't calculate the crossover parts properly. Other woofers are the same. Here's a few samples from different spec sheets. This is an 8 ohm woofer. Here's another 8 ohm woofer. We can see that it's quite common to have a changing impedance plot. Sorry, my tweeter measurements didn't work out, but here's a few examples from different manufacturers' spec sheets. This is a compression driver. Here's some dome tweeters. So you can see that their impedance changes as well with frequency. And this is common with all drivers. I tried all these sites, they're all garbage.
So then how do we go about designing a crossover? If we can't use these calculators, how do manufacturers do it? How do I do it? Well, I use real data from the drivers, like I've shown you here, and I put them into a crossover simulator, an actual piece of software that uses all the data, the frequency response, the phase, which I haven't talked about, that's another reason why these things don't work, as well as the impedance. And the software uses all this data to construct a real response based on the components you put into it. Well, I hope this has been helpful to you, and you can now see why I'm hesitant to recommend these crossover calculators, and I hope you will not use them in future projects. Instead, learn how to do crossover design or pick a project that's already worked out for you, and I think you'll have much more success. There's lots of kits available, projects out there that you can choose from. Just make sure you vet them and don't pick a piece of junk, because you're spending a lot of money and spending a lot of time building them, so pick something that's actually good. If you enjoyed this and want to see more, please check out this video right here or subscribe right here. Thanks for watching.